Okay, today we're going to go over the limit comparison test, which is an infinite series test very similar to the direct comparison test. And it's actually quite simple. So let's say, for instance, before I go over the conditions, let's say that you had a series from n equals 1 to infinity of a sub n. Now, if you wanted to find whether or not this converged using the limit comparison test, you would find a separate similar series. Let's say that's n equals 1 to infinity b sub n. If b sub n converges and the limit as n approaches infinity of a sub n over b sub n is positive and non-infinite, then the infinite series of a sub n will converge. However, if the infinite series of b sub n diverges and the limit as n approaches infinity, a sub n over b sub n is positive and not infinite, then the infinite series of a sub n will diverge. So the state of convergence of a sub n is entirely dependent on the state of convergence of b sub n. Okay, so let's try to alter this series a little bit. This is practice problem 1. And we're going to assign that altered series to b sub n. So let's say that the infinite series from n equals 1 to infinity of 1 over, let's say, n. And this is going to be b sub n. It's slightly altered from the original because all we're doing is we're getting rid of this plus 1 in the denominator. And of course, the square root of n squared is n. So that's how we ended up with this infinite series. And of course, this is a harmonic series. So we can say that this series right here, b sub n, diverges by harmonic. Now, with the limit comparison test, we can find whether or not this diverges if the limit as n approaches infinity of a sub n over b sub n is positive and infinite. So let's do that. Okay, we could simplify this a little further. And we end up with n over square root of n squared plus 1. Now this right here is actually equal to 1. And since 1 is positive and it is not infinite, then we can safely say that this original series of n equals 1 to infinity, 1 over the square root of n squared plus 1, diverges by the limit comparison test. Okay, so this is practice problem 2. We're going to start off by trying to find this infinite series of b sub n. So let's write down the series from n equals 1 to infinity of, let's say, 5/6 n. Now, we're choosing this one. All I did was get rid of this plus 1, and this is a little simplified. So that is it for b sub n. Now we just have to find whether or not it converges. So we can use the geometric series test. We can see that the absolute value of r is equal to 5/6, which is less than 1, meaning that this series over here, the infinite series of what we call b sub n, converges by the geometric series test. So I'll just write that here. Now, that means that this series, our initial series of a sub n, converges if the limit as n approaches infinity of a sub n over b sub n is positive and non-infinite. So let's find out if it truly is. Okay, we can simplify this a little further by saying that this is equal to the limit as n approaches infinity of 6 to the power of n over 6 to the power of n plus 1. Now we're only going to focus on the largest terms. That's typically what you do in limits as n approaches infinity. So this part over here is pretty much irrelevant. So we really just end up with 1. This is our final answer. And 1 is not only a constant, or not only a positive, but it's non-infinite, meaning that this initial series converges since our b sub n converges, and it has met all conditions for the limit comparison test.